Good morning, friends. Am I audible clearly?
Good morning, sir.
Okay. So where we are in previous lecture? Can anyone please tell me? Because it's long time we have not conducted lecture. Whether we have completed first chapter or no?
No, sir. Kaplan turbine राहिलाय.
Okay, very good. Thank you, Shivanjali. Okay. So we are in first chapter. Actually, other divisions are ahead from you. Whether you started or completed the assignment, writing of assignment.
MCQ अपलोड केले नाहीत का तुम्ही?
हा सर MCQ आले नाही.
केलेत ना?
सर नाही झाले. सर डेडलाईन केव्हापर्यंतची आहे?
डेडलाईन नाही दिली मी अजून. 1 सेकंड मी चेकच करतो आता. आणि तुमच्या असाइनमेंट साठी लिंक दिली आहे ना भानु सरांनी असाइनमेंट सबमिट करण्यासाठी?
हो
Yes,
सर.
sir.
सगळ्या सब्जेक्ट साठी दिले ना?
हो सर.
ठीक आहे, ओके. So you do one thing. Is this visible slide?
Yes, sir.
Yes.
Yes, sir.
येस सर.
Yes, sir.
Pelton turbine, Francis turbine, and the Kaplan turbine. Okay. So what we have seen in previous lectures, we have covered two turbines. The turbines are the devices which are used to generate the electricity or to produce the power. Okay, so power can be produced by many methods. So out of these, hydroelectric power plant are most important power plant or which generate maximum amount of energy. Okay, so the turbines which are using or used in the hydroelectric power plants, these are Pelton wheel turbine, second one is the Francis turbine, and third one is the Kaplan turbine. Out of which we have seen two turbines. First one is the Pelton turbine. So Pelton turbine is mainly work on or it is the impulse turbine. The flowing at the turbine is tangential flow, so we call it as tangential flow impulse turbine. Okay, in that the water jet is created which consists only a kinetic energy, and with that energy water jet strike to the bucket of a turbine and the turbine get rotated. Okay, and one of the shaft of this turbine connected to the generator, and when this shaft start rotating, the current will produce. Okay, this is related to the Pelton turbine. Now, second one is the Francis turbine. So in front of you, you have a slide of Francis turbine. So Francis turbine is most efficient turbine compared to other turbines. So the Francis turbine is used for medium head and for medium water quantity. Okay, so the Francis turbine work or Francis turbine at the in the turbine water having both pressure energy and kinetic energy. Okay, and water enters radially. Radially म्हणजे त्याच्या भोवती सभोवतालीने water enter होतं and it will leave axially. So when water enters radially, it pressure energy act on the turbine. So high pressure develop on one side and low pressure on the other side. So from high pressure side, force will generate, and this force push that vane towards this direction, in this direction. Okay, ज्या direction ने force आहे त्या direction मध्ये. And when it leaves at that time, due to the impulse force, again force is applied, that is the impulse force. Okay, so two types of forces are there. So this turbine is work on reaction force as well as impulse force. Okay, so this is mixed type flow turbine. Now next one is the Kaplan turbine. Okay, this one is the last turbine from our syllabus. So generally these turbines are used in the hydroelectric power plant. Now when we can use Kaplan turbine? So whenever the head of water is very low, near about 50 meter, okay, so or from 20 to 50, so there is a range, there may be change in the head, so we can use up to that range Kaplan turbine where the discharge is more. Okay, Kaplan turbine is, as compared to the other turbines, it having low efficiency. Okay, now see this one is the actual image of a Kaplan turbine. You can observe here one white color runner is provided. So this runner is called as hub or boss, and the vanes are mounted angularly on that with some angle to that boss. Okay, the same image or a same device is used in ship also. Okay, जहाजामध्ये सुद्धा सेम प्रकारचं एक डिव्हाइस यूज केले जातं. तुम्ही ऑब्झर्व केले मूवीज मध्ये वगैरे पाठीमागच्या बाजूला एक अशा प्रकारचे शिप बसवलेलं असतं जे रोटेट होत असते जहाजाला पुढे ढकलण्यासाठी. हॅव यू ऑब्झर्व इट?
सर ते फॅन सारखं का?
हा, फॅन सारखं पाठीमाग असते ते, बघितलं?
येस सर.
Yeah. So this that whatever used in the ship, these are the propeller shaft. Okay, or propellers, not shaft. These are the propellers, and here this one is the Kaplan turbine. So there is a there is one difference between the turbine and propeller. So what is the difference? The vanes of Kaplan turbine can be rotate like this. ओके, हे जे ब्लेड्स आहेत ते इतर रोटेट होऊ शकतात कपलन टर्बाइन मध्ये, and in propeller they will not rotate or the vanes will not rotate. Okay, what do you understood difference? Very simple difference. Okay. So now this is the diagram for Kaplan turbine. I will explain here construction, then working, and then we will see one simple video. And with this, this point will over. And with this point, again, our chapter is also over. Okay. Now observe here carefully. I will explain the construction. So in construction, we have scroll casing. Scroll casing is used to flow water towards the turbine. Now, after scroll casing, guide vanes are provided. So the function of guide vanes to provide water towards the, or direct water, give direction to the water towards the turbine. And scroll casing carry water from dam towards the turbine. So this is the function of that scroll casing and the guide vane. Here scroll casing is again same as the we have seen in the Francis turbine. Here also same scroll casing can be used. Then adjustable runner vanes. Adjustable, it means the runner vanes can be swing along their axis. Okay, when water flow is low, at that time we try to make them horizontal, and when water flow is high, we try to make them vertical, not perfectly 90-degree. Okay, some angle should be there, otherwise it will not rotate. Okay, then these adjustable runner blades are fixed on the hub or boss. This is called as hub or boss in the Kaplan turbine. Then the shaft, that hub is attached to shaft. When turbine rotate, the shaft also start rotate. This shaft is again connected to the generator, and generator will convert mechanical energy into the electrical energy. So here again the pressure drops down below the atmospheric pressure. So again we are using here a draft tube. So what is the function of draft tube? So the function of draft tube, or the draft tube means the tubes or the pipes, bigger pipes, which consist or which area of the pipe goes on increasing. Such pipes are called as draft tubes. Okay. Then here it is tail rest. Tail rest, it means some maybe some tank, or we can leave water to the river. Okay, so this is the construction of this Kaplan turbine. Now working. Here again we have same working. When water flows through the casing, it moves around the turbine, and then it will drop from the guide vanes in the downward direction. So water enters here axially. Water enters here axially, which consists pressure energy. Okay, त्याच्यामध्ये फक्त pressure energy आहे, because it was not traveling from the height. Okay, so and leaves also axial. So this turbine is axial flow turbine. So these turbines are the axial flow turbine. Okay. And when it enters or dashes or strikes to that vanes, it will slide over the blades, and due to that the force will act, reaction force, lift force will act on the vane, and due to that this hub start rotating. ओके, एकदम सिंपल याचं वर्किंग आहे. याच्यामधून पाणी येते इकडून या स्क्रोल केसिंग मधून. ओके, ते जे पाणी आहे ते इथं आल्यानंतर गाईड व्हेनच्या माध्यमातून सगळ्या बाजूने समान पाणी पडावं, त्याच्यासाठी गाईड व्हेन मधून त्याला डायरेक्शन दिलेले आहे. ओके, ज्या वेळेला इथून पाणी आत येते त्यावेळेला त्याच्यामध्ये प्रेशर एनर्जी आहे, ते त्या प्रेशर एनर्जीने त्या व्हेन्स वरती ड्रॉप होते. त्याच्यावरती पडल्यानंतर त्याची जी एनर्जी आहे त्या एनर्जीमुळे ह्या व्हेन्सला या बाजूने फोर्स ऍक्ट होतोय, आणि त्याच्यामुळे हे व्हेन्स काय होतात, फिरायला चालू होतात, किंवा त्याच्यामुळे हब फिरायला चालू होतो, आणि हब मुळे शाफ्ट फिरायला चालू होतो. सो here we convert hydraulic energy into the mechanical energy. So available energy here is in the form of pressure energy. Okay, so this turbine is purely, we can say, reaction turbine, and the flow here is axial flow. Axial. ओके, आणि त्याच्यानंतर मग इथून पाणी हे नदीमध्ये सोडलं जातं. गेट इट?
Yes, sir.
I'll show you one video also of that turbine, then you draw this diagram. Is anyone having any doubt? That whirl chamber is also provided here. Whirl chamber is related to, if you want to see here something or about this shaft and all these things. Whirling is actually the velocity of that what we can say, vanes, one of the velocity. Okay. So I will show you one video of Kaplan turbine. Okay. Now you please observe
Turbines
this.
are suitable for power
This is visible?
extraction when water energy is available at low head and high
Yes, sir.
flow rate,
Okay. So this one is the
which means
Kaplan
they are
turbine.
suitable for operation when water is stored in a big reservoir at a relatively shallow
This one is the
altitude.
3D model
In
created on the
Kaplan
software.
turbine,
So this
flow is
is the
entered through a spiral
water
casing.
flowing all
Decreasing
around
area
the
of casing
turbine.
makes sure that flow is entered to the central portion, almost
So
at uniform
it
velocity
is very
throughout the
important
perimeter.
to flow of water from all
Water
sides in
after
equal
crossing the
quantity.
guide vanes passes over the runner.
So the guide vanes
Finally, it leaves through a draft
provide
tube.
passage towards the runner.
Most important part of
So
Kaplan
this one is
turbine.
the very व्हिडिओचा
Cross
आवाज ना
section of runner
डिस्कनेक्ट केला
blade
होता.
will have a curved shape.
What do
When water flows over it, it will induce a
Sir,
lift
I-
force due to airfoil effect.
now see?
सर आवाज येतोय
Tangential
व्यवस्थित?
component of lift force will make the runner
येतोय?
rotate.
स्टार्टिंग पासून प्ले करायला ओके
Kaplan turbines are suitable for power extraction when water energy is available at low head and high flow rate, which means they are suitable for operation when water is stored in a big reservoir at a relatively shallow altitude. In Kaplan turbine, flow is entered through a spiral casing. Decreasing area of casing makes sure that flow is entered to the central portion, almost at uniform velocity, throughout the perimeter. Water after crossing the guide vanes passes over the runner. Finally, it leaves through a draft tube. Most important part of Kaplan turbine is its runner. Cross section of runner blade will have a curved shape. When water flows over it, it will induce a lift force due to airfoil effect. Tangential component of lift force will make the runner rotate. This rotation is transferred to a generator for electricity production.
स्टॉप झाले काय?
Yes, sir.
हा सर.
स्टॉप झाले.
हो सर.
One second.
Kaplan turbines are axial flow machines, where absolute velocity of flow is parallel to
आता
axis
दिसतंय?
of
ऐकू येतंय
turbine.
ना सगळं?
Water is precisely made to pass through runner blades, with help of a shroud. Power demand may fluctuate over time. A governing mechanism, which controls position of guide vanes, is used to control water
With the help
flow
of
rate.
governing mechanism, we can move this.
This can meet for varying power
So
demand.
they will move in one direction.
Blades of Kaplan turbine are designed to operate under a wide range of operating conditions.
So this is the design
A
of
rotating blade
blades.
experiences
So they
relative
extract
velocity of
maximum
flow.
amount of energy from the
The fundamental thing in blade design is relative velocity of fluid flow should be at optimum angle of attack at all cross sections. Even though absolute velocity is axial, relative velocity will be inclined, depending upon blade velocity. Inclination of relative velocity
So we will
increases
the
as we move from root to tip
actual
due
velocity,
to
we will
increasing
the
blade
relative
velocity. There should be continuous twist in blade, from root to tip, so that at every cross section the angle of attack is optimum. With varying flow condition, relative velocity will change drastically. Kaplan turbine blades are adjustable. When flow rate is high, relative velocity of flow will be more axial, so blade should pitch vertically.
When the flow is
If flow
more,
rate is low,
we rotate
relative
that
velocity of flow is more tangential,
lens,
so blades are pitched in
and when
tangential
the flow
direction.
is low, we move like this.
In short, pitching action of blade makes sure that blade is still in optimum angle of attack, even under varying flow.
So pitching, this process is called as pitching.
Apart
When
from controlling the flow rate,
will be
guide
used
vanes
for
have got one more
varying
function.
flow
They help in controlling swirl of
of the
flow.
water.
If guide vanes were not present, the flow would be highly swirling in nature, due to its tangential entry. Such a flow would reduce performance of turbine drastically, due to its poor angle of attack. So guide vanes control swirl of flow, for optimum angle of attack. Biggest challenge in design of Kaplan turbine is how to overcome problem of cavitation, which causes material erosion and vibration. Cavitation is unavoidable in Kaplan turbine, since in most of the regions, pressure goes very low. But damage due to cavitation can be reduced by using suitable blade material, and use of anti-cavitation fin.
So this is maybe the
Draft
material
tube, which
used
transforms
for the
dynamic pressure
blades.
to static pressure, due to its increasing area, also helps in reducing cavitation effect. Thank you. Hope you got a good understanding on Kaplan turbines.
Okay. Have you understood?
Yes, sir.
Yes, sir.
Now do one thing, draw the diagram for this turbine. So this one is the schematic diagram that you have to draw. Is this visible?
Yes, sir.
Yes, sir.
Okay. Then draw this diagram.
The all-new Ford 2.0 EcoBlue diesel delivers the combined with a special focus on modules and fuel pump. The two-intake system ensures access for higher torque, lower emissions and reduced fuel consumption. With this, the new Transit line delivers increased low-end rated exhaust gas recirculation system integrated into the cylinder head. The innovative concept saves weight and space. The EGR is the first stage of the new
सर ते डायग्राम फुल स्क्रीन करा ना.
Okay. So with this point, we covered first chapter. Is anyone having any doubt? Then they can ask here. Or someone is remaining, or who, any diagram is remaining to draw, then we will draw here. जर कोणाची डायग्राम एखादी पाठीमागची काढायची राहिली असेल तरी पण आपण ती ओपन करून आता काढूया. Because we have time. Otherwise, we have to move towards next chapter. And complete assignment today. ठीक आहे, आता मी प्रोव्हाइड करतो, बघतो जमते का.
सर
हा बोला साक्षी.
सर एकदा तुम्ही सेंट्रिफ्युगल पंपला थोडस रिवाइज करून देता का?
सेंट्रिफ्युगल पंप का? हा म्हणजे परत एक्सप्लेन करू का?
हा सर शॉर्ट मध्ये थोडं
हा.
रिव्हिजन साठी.
ठीक
सर
आहे, ठीक आहे. हा यस.
सर एकदा हे पीपीटी स्लाइड 1 पासून घ्या की सर, म्हणजे आम्ही क्रॉस चेक करतो कोणकोणते डायग्राम राहिल्यात आणि केल्यात.
हा हा चालतंय, घेतो पण आणि थोडं रिव्हिजन पण घेऊ सगळ्यांची, थोडं थोडं शॉर्ट मध्ये
हो
सांगतो
सर.
सगळे.
हो सर.
येस सर.
ओके, तुमचं झाल्यानंतर सांगा मला.
सर आणि जेव्हा प्रोजेक्ट भेटेल, असाइनमेंट द्याल तुम्ही, तर त्याचा म्हणजे केव्हापर्यंत सबमिट करावं लागणार एमसीक्यू आणि हे डायग्राम
ठीक आहे.
वगैरे सोबत?
मी सांगतो ना तुम्हाला.
हा.
तुमचं कम्प्लीट झाले की त्याच्यावर सबमिट करा तुम्ही, काय अडचण नाही, कारण त्याला ऑप्शन दिलेले असणार आहेत ना.
ठीक सर, 1-2 तारखेपर्यंत ठीक आहे का टायमिंग की?
1-2 तारीख आता एवढे नाही दिवस लागणार तुम्हाला, मला वाटतं.
ठीक आहे
डायग्राम
सर.
तर
तेव्हा
काढायचे, डायग्राम आणि एमसीक्यू ला 30 एमसीक्यू लिहायचे तुम्हाला कोणते.
तसं
थोडा वेळ.
परवापर्यंत चालेल का?
हा चालतंय चालतंय.
थँक्यू सर.
जेवढं होईल तेवढं फास्ट कव्हर करत चला. त्यात तुम्हाला ऑप्शन दिले असतील त्यांनी, असाइनमेंट नंबर 1 म्हणजे ड्रॉप डाऊन मध्ये ऑप्शन दिले असतील सरांनी. मी चेक केलंय का ते कसा एकदा?
हो सर.
सर
कारण मी बाकीच्या डिव्हिजनला लिंक दिली सर, सरांनी मला म्हटले की तुम्ही जी डिव्हिजनला लिंक देऊ नका, मी ऑलरेडी दिलेली आहे.
सर किती एमसीक्यू लिहायचे?
30 एमसीक्यू लिहायचे, सगळ्यावरचे थोडे थोडे येतील अशा प्रकारे 30 लिहायचे.
ओके सर.
सर आणि मागचे 2-3 लेक्चर
कोणते?
तुम्ही कधी अपलोड करणार?
काय अपलोड
मागच्या
करायचं?
2-3 दिवसांचे लेक्चर सर युट्यूब वरती.
हा लेक्चर काय करतो मी आज आज करतो. आता पहिल्यांदा
थँक्यू
तुम्हाला
सर.
एमसीक्यू देतो पहिल्यांदा.
ओव्हर सर.
झालं? हा ठीक, एकच मिनिट. हा एमसीक्यू ची लिंक थोडी क्रिएट करून टाकायला लागलो मी. वन सेकंड होल्ड ऑन. नंतर राहिले त्यांनी काढून घ्या, अजून लिंक टाकतो तोपर्यंत. ओके, पीपीटी ची टाकलेली आहे का तुम्हाला मी एक्स्ट्रा? ठीक आहे ठीक आहे. बाकीचे पीपीटी कोणाला टाकले नाहीत, फक्त तुमच्या डिव्हिजनलाच टाकलेले आहेत. हा डायरीला टाकतोय बघा बरं, जरा चेक करा टाकली आता दिसते का बघा जरा. एमसीक्यू ऑफ चॅप्टर 1 त्याच्या खाली एक लिंक दिलेली आहे मी, बघा बरं चेक करा ओपन होते का. पेल्टन टर्बाइन, फ्रान्सिस टर्बाइन मागच्या लेक्चरची एक लिंक टाकायची राहिलेली आहे, आणि रेसिप्रोकेटिंग कॉम्प्रेसर वेन कॉम्प्रेसर चेक राहिलेली आहे. ठीक आहे. दिसते का बघा बरं लिंक, थोडं चेक करा.
नो सर, नाही दिसत. अजून नाही दिसत.
अजून दिसत नाही का? ठीक आहे, अजून थोड्या वेळानं बघू आपण.
ओके.
हा सर झाली ओपन.
दिसते सर.
दिसते ना?
येस सर.
पहिल्या सुरुवातीला नोट्सची लिंक आहे ऍडिशनल मटेरियल मध्ये, दुसऱ्या नंबरला पीपीटी ची लिंक्स आहे, आणि तिसऱ्या नंबरला एमसीक्यू ची आहे. ओके, ते एमसीक्यू मध्ये
सर आणि ते तिथं
हम्म.
एक्सपेरिमेंटचं काय आहे?
कुठं आहे
ते बीएमई आणि वर्कशॉप सर लिहिलेलं आहे ना काहीतरी?
मला इथे दिसत नाही, कशात म्हणताय तुम्ही, काय कळलं मला.
टीचिंग डायरी मध्ये
हा.
ते मेकॅनिकल वर्कशॉप्स एक्सपेरिमेंट्स आणि बीएमई एक्सपेरिमेंट करून इथंच लिहिलेलं आहे
हा,
ऍडिशनल
मग ते
नोट्सच्या
आपल्याला
साईड
एक्सपेरिमेंट शेवटी कंडक्ट करायचे आहेत ऑनलाईन, त्याच्यासाठी आहेत. आणि वर्कशॉप पण ऍक्च्युअली तुम्हाला पुढच्या चॅप्टर मध्ये लक्षात येईल की वर्कशॉप मध्ये तुम्हाला लेथ मशीन वगैरे हँडल करायच्या होत्या, परंतु त्या फक्त आता आपण बघणार आहोत त्याचं कन्स्ट्रक्शन वर्किंग कसं आहे, कसं वर्क होतं, कोणते ऑपरेशन परफॉर्म होतात ते बघणार आहोत. आणि त्याच्यावरून तुम्हाला एक रिपोर्ट क्रिएट करायचा आहे. ओके, लेथ मशीन साठी सपोज लेथ मशीन आहे किंवा ड्रिलिंग मशीन आहे, त्यासाठी तुम्ही काय बघितलं, काय ऑपरेशन परफॉर्म होतात त्याच्यावरती, ते बघून त्याच्यावरून एक रिपोर्ट लिहायचा आणि त्याची PDF तयार करून त्या लिंक वरती अपलोड करायची. ओके, अशा प्रकारचं ते असणार आहे. मला वाटतं सगळ्यांचे झाले असेल ड्रॉय करायची. आपण पहिल्यापासून एकदा रिव्हिजन घेऊ आणि मग थांबू आपण. And from tomorrow we will see next chapter.
सर युनिट टेस्टला एवढे MCQ सफिशियंट आहेत का?
हा, एवढे सफिशियंट आहे. मला वाटतं 57, 55 पर्यंत काय आहेत वाटतं.
57.
Okay. So the basic mechanical engineering. So in basic mechanical engineering, it means we are going to learn in that subject about the basic of some machineries. So from that, in this syllabus, we have 4 chapters. So first one is the pump, compressor, turbine. So this is the syllabus for pump, compressor, turbine, in which pump, compressor, and turbine. In pump, we have 2 pumps. Okay, that is reciprocating pump and centrifugal pump. So the reciprocating pump is positive displacement pump and centrifugal pump is the rotary pump. Okay. Now reciprocating pump. So this one is the reciprocating pump. So here we have cylinder, piston, connecting rod, crank pin, and one suction pipe and one delivery pipe. So how it works? When this crank is connected to the prime mover, when prime mover start, this crank also start rotating. The rotation of this crank with the help of connecting rod and piston rod is not shown here. So with the help of these 2 rods, this rotating motion of the crank will convert into the reciprocating motion. Okay, it will convert into the reciprocating motion. So when pistons start moving from inner dead center, this one is the inner dead center. Okay, this one is the inner dead center. When pistons start moving from inner dead center towards the outer dead center, the vacuum will create inside the cylinder. Okay, or the negative pressure. So to feel that, water is, or the suction of water takes place from the reservoir or here from the sump, and it accumulates the space in the cylinder here in first stroke. Okay. Now second stroke. When pistons start moving from outer dead center towards the inner dead center, at that time the suction valve get closed and water inside the cylinder trapped into this chamber. And as piston move towards left side, it will create pressure on this water, and at the same time the delivery valve get open and the water from the cylinder enters or flow into the delivery pipe. Okay, with the delivery pipe we can transfer this water at required height. Okay, this is simple function of double acting reciprocating pump. But sorry, single acting reciprocating pump. But there is one problem, that we do not get water or the discharge for every stroke. So one stroke is empty. Okay, that is suction stroke. And on the another stroke, we get water. Okay. So to avoid that or to eliminate this problem, another type of pump is provided. This pump is called as double acting reciprocating pump. So in double acting reciprocating pumps, there is a simple change in structure, that is here. So the two pipes are added for single acting reciprocating pump. One from suction side and one from the delivery, for the delivery. Okay, so for every stroke in this, for every stroke, it means when piston move from inner dead center towards the outer dead center, we get discharge from the delivery pipe D2, and when piston move from outer dead center to the inner dead center, we get discharge from D1. Okay, all other remaining process is same as that of single acting reciprocating pump. Get it?
Yes, sir.
Yes, sir.
Okay. Now centrifugal pump. This is mostly used or applicable pump in agriculture sector also, because this pump provide maximum discharge and continuous flow. Okay, हा जो पंप आहे तो मॅक्झिमम डिस्चार्ज देतो, त्याचबरोबर तो कंटिन्युअस डिस्चार्ज देतो. Okay, so what is how it works? So impeller is here having wrong direction in this diagram. ज्या वेळेला water, before starting the centrifugal pump, one process we have to perform, and that process is nothing but which process? Which is this process?
Priming.
Priming. Very good. मला वाटतं कोणालाच आता लक्षात राहिलं नसेल. Good. So priming. Now what is the priming? Priming is the process of filling water into the suction pipe, casing, and up to the delivery. Okay. When we start motor, at that time, the shaft here also start rotating, and due to that, or the impeller mounted on the shaft also start rotating. When impeller start rotating, so the water which is present in the impeller flows in outward direction with the centrifugal force. So this water having pressure energy as well as kinetic energy. So when this water flows out of this impeller, so cavity will form here. या ठिकाणी निगेटिव्ह प्रेशर क्रिएट होईल, जो भरून काढण्यासाठी त्याच्या भोवती असणारे जे वॉटर आहे हे व्हॅक्यूम ओढून घेईल. It will suck water nearest to water. So this process continues, and at last, water from the sump will suck, and this process will continue. Okay. So whatever water enters into the casing, okay, with the pressure energy and kinetic energy, so the casing is designed in such a way that the diameter of casing goes on increasing. So we know that when the diameter of pipe goes on increasing, so it will increase the pressure of water. Okay, and here we increase the pressure of water in casing. Why? Because if we want head, we require pressure in the water. Okay, get it?
Yes, sir.
Yes, sir.
Yes, sir.
Because we know that P is equal to rho G H. It means head. If we want head, we have to increase the pressure. So for that, we are using these equipments to add pressure into the water to lift water from lower level to higher level, or from one place to another place. Okay. Next are the compressor. So reciprocating compressor. Reciprocating compressor having same design, or basic design is of same reciprocating pump. Okay, but the working fluid is air here, and in pump it is water. Okay. So here again same process we have. This is the delivery side, this one is the suction side, this one is the piston. Piston, if you want to run this device, we need some external power source. So when pistons start moving in the downward direction, so what will happen here? Cavity will form, or the vacuum, not cavity actually, cavity is a different word. Vacuum will form in the chamber. This one is the chamber. Here vacuum, or we can say negative pressure, form here, which is negative pressure. It means which is below the atmospheric pressure. So this vacuum suck water from the atmosphere. Okay, from atmosphere, due to this vacuum, what air enters into this chamber in first row. Okay, and accumulate all the space formed by moving of this piston. Now second stroke, when pistons start moving in upward direction, at that time this air trapped in that chamber, and when piston moving in upward direction, the air will be pressurized, and at a certain point delivery valve get open, and this pressurized air is moving through delivery valve or delivery pipe, and this air can be stored into the tank for further use of compressed air. Okay, this is simple working of a reciprocating compressor. हा compressor आपण बऱ्याच ठिकाणी बघत असतो. Okay, we have seen what are the use of compressed air. If you got some more, if you can find some more uses or applications, you can write there. So this one is the vane blower. So vane blower is again same. So the compressor work on the principle that reducing the volume. Okay, compressor work on that principle that reducing, we have to trap some air in some chamber, and then we have to decrease the volume, so we get pressurized air. Okay, so here also same process happen. For that 4 chambers are created. This is the casing, these are the vanes which is inserted into that slots, and the springs are attached to that vanes. So springs are take care to contact of that vanes with the casing. So here when air come out or come in from the atmosphere in this first chamber, we can say volume V1, and when we start prime mover, what will happen? This air, trapped air in this chamber will move along with that 2 vanes. And if you observe here, the design of this casing is made in such a way that when it starts rotating, the volume of that chamber goes on decreasing. Okay, can you understand?
सर ही पण डायग्राम काढायची.
वेन ब्लोअर सर शिकवलं नाही बहुतेक.
घेतलंच नव्हतं सर हे.
हे राहिलं होतं काय?
हो सर.
ओके ओके, घेऊ आपण, काय अडचण नाही. मग आता सांगतो तुम्हाला कसं कसं आहे बघा. Now see here, So this is the vane blower. This is the second type of compressor that we can use to compress the air. So these are the constructional part of the vane blower. So this one is the casing. Casing is the cylindrical chamber, okay, which consists two ports for air inlet and air outlet. Okay. In that, one rotating disc is mounted eccentrically, okay, with some distance from the center of that casing. Slots are provided on the rotating disc. Here 4 slots are provided. In some blowers, there may be more than 4 slots. So in that slots, compression springs are mounted. Compression springs method. Do you know compression springs?
Yes, sir.
Yes, sir.
Where you find it? There are two types of the springs, compression springs and the tensile spring. आपले जे खटक्याचे पेन होते त्याच्यामधल्या ज्या स्प्रिंग्स होत्या त्या कॉम्प्रेशन स्प्रिंग्स आहेत. खटक्याचे पेन माहित आहेत आपल्याकडे होते अगोदर.
Yes, sir.
हो, त्याच्यामध्ये जी स्प्रिंग यूज केली जाते, ओके, त्याच्यामध्ये जी स्प्रिंग यूज केली जाते ती कॉम्प्रेशन स्प्रिंग आहे. आणि टेन्साइल स्प्रिंग म्हणजे जे आपण बायसिकलच्या स्टँडला किंवा मोटरसायकलच्या स्टँडला जी वापरलेली स्प्रिंग आहे ती स्प्रिंग आहे टेन्साइल स्प्रिंग. So this spring is the compression spring. With that compression spring, these vanes are fixed here in the slot. Okay. मग काय होतंय, ह्या स्प्रिंग मुळे ही जी वेन आहे ही या केसिंगच्या कॉन्टॅक्ट मध्ये राहतात काय. ज्या वेळेला हा प्राइम मूव्हर इथं शाफ्ट आहे याला प्राइम मूव्हर कनेक्ट केलेला आहे, ज्या वेळेला हा आपण रोटेट करतो, ज्या वेळेला प्राइम मूव्हर रोटेट होतो त्यावेळेला त्याच्याबरोबर त्या प्राइम मूव्हर बरोबर ही डिस्क त्या वेन्स रोटेट व्हायला चालू होतात. हे केसिंग स्टेशनरी आहे. पहिल्या सुरुवातीला इथे काय होतं, इथलं एअर जे आहे याच्यामध्ये सक केली जाते. ओके. आणि ज्या वेळेला हे रोटेट होतं त्यावेळेला इथलं जे व्हॉल्यूम आहे ते हळूहळू रिड्यूस होत जातं आणि या ठिकाणी ज्या वेळेला एअर येते त्यावेळेला ती कशी असते, इथं आली की ती थोडीशी कॉम्प्रेस होते. त्याच्यानंतर ती ज्या वेळेला थर्ड चेंबर मध्ये म्हणजे आउटलेटच्या जवळ येईल त्यावेळेला ती जास्त प्रेशरायझड असते आणि ही प्रेशरायझड एअर जी आहे ती आपण त्याच्यामधून बाहेर घेतो. Okay, so this process continues. This is the working of vane blower. समजलं का? त्याची व्हिडिओ दाखवू, थांबा एक मिनिट, याची व्हिडिओ पण आहे छोटीशी. राहिला कस काय मला काय कळलं नाही. One second. One second. G. Yes.
Made with vanes or impellers. These types of compressors are called rotary compressors. Rotary compressors typically consist of a cylindrical housing with adjustable rotary vanes, an inlet, and an outlet. The vanes are on an off-center drive shaft. As the shaft rotates, the vanes slide in and out to maintain contact with the cylindrical compressor wall. As they do, they create chambers within the cylinder of varying sizes. Air enters at the largest chamber. As the vanes rotate, they retract, causing the chamber to get smaller and compress the air. Air exits at the smallest chamber. Rotary compressors are typically free of the vibration and pulsation that occurs with reciprocating compressors.
Hello, understood?
Yes, sir.
Yes, sir.
Very simple device again here. Uh, झालं sir, 2 minutes. So with this we will stop here. Okay.
सर
Yes.
लो ब्लोअर पण राहिले वाटतं सर.
नाही लो ब्लोअर सिलेबसला नाही आपला.
ओके.
हा तो नाही सिलेबसला. व्हेन ब्लोअर फक्त आहे. So with this we will stop here. I will add a link from another division for the vent compressor. Don't worry about link. Okay. जर कोणाला शंका असतील तर विचारा, मात्र ज्या वेळेला शंका असतील त्यावेळेला विचारा. कसं होतंय 3 दिवस सोमवार, मंगळवार आणि बुधवार लेक्चर झाले की त्याच्यानंतर डायरेक्ट पुढच्या सोमवारी तुमचं लेक्चर आहे. ओके.
सर आणि तुमचे मागचे लेक्चर्स थोडे पाहिजे होते, तर तुम्ही जर लिंक टाकाल तर बरं होईल.
हा फक्त 2 याच्या राहिलेत लिंक मला वाटतं, वेन आणि रेसिप्रोकेटिंगच्या राहिल्यात. रेसिप्रोकेटिंग तुमची असेलच, वेनची पण मी टाकतो.
हो.
ओके.
हो.
सो
सर अटेंडन्स.
हा अटेंडन्स घ्यायची आहे, तेच विचार करत होता. सो रोल नंबर 1
प्रेझेंट सर.
2
प्रेझेंट सर.
3 रोल नंबर 3. Okay, Snehal is present. 4 roll number 4 Komal Dekle.
Present sir.
5
Present.
6
प्रेझेंट सर.
7
प्रेझेंट सर.
8
प्रेझेंट सर.
9
Present sir.
10
Present sir.
11 roll number 11 absent.
प्रेझेंट सर.
12
प्रेझेंट सर.
13 13
Present, sir.
okay 14
Present, sir.
15
प्रेझेंट सर.
16
प्रेझेंट सर.
17
Present, sir.
18
प्रेझेंट सर.
19 20 okay Aditya 20 absent 21
प्रेझेंट.
22 okay 23
प्रेझेंट सर.
24
प्रेझेंट सर.
25
प्रेझेंट सर.
26 roll number 26 absent 27
प्रेझेंट सर.
28
Yes sir.
9 29 30
येस सर.
31 31
प्रेझेंट सर.
okay 32
Yes, sir.
33
Present, sir.
34
प्रेझेंट सर.
35 35 absent 36
प्रेझेंट सर.
37
प्रेझेंट सर.
38 38 absent 39
Sir.
40
प्रेझेंट सर.
41
Present, sir.
42,
Present, sir.
43,
Present, sir.
44.
Present,
Okay.
sir.
Okay, 45,
Present, sir.
46, 46, 47,
Present, sir.
48,
Present, sir.
49,
Present, sir.
50,
Present, sir.
51,
Present,
52,
present, sir.
53, 53, absent. 54,
Present, sir.
55,
Present, sir.
56, 56, absent. 57,
Yes, sir.
58,
Present, sir.
59,
Present, sir.
60,
Yes, sir.
61,
Present, sir.
62,
Present, sir.
63,
Present, sir.
64, 64. Okay. So I will call absent roll number. Please check. Roll number 20, 26,
Sir, 20 is present.
20 is present. Okay. 26, 35, 46, 53, 56, and 64. Okay, with this, we will stop here. We will meet in next lecture.